Hi everyone. I chose to review fraction strips and towers. From the research, we know that manipulatives are important. They allow students to articulate their thinking and construct models for abstract mathematical ideas and processes. As one of the readings stated, the most valuable learning occurs when students actively construct their own mathematical understanding. This is something that the use of manipulatives encourages. I think the best way to explore fraction strips and towers as a thinking tool is to examine how they might be used to solve a problem. So let's look at the lizard problem. And this is a task that I would use in my classroom. Two lizards go for a walk. One lizard walks 3/4 of a mile. The other lizard walks 3/8 of a mile. Which lizard walked the longest distance? Let's explore how fraction strips can help students solve this problem. Fraction strips are rectangular pieces that represent different parts of the same whole. They can be cut apart and manipulated to see how various parts can be added together to make the whole, or they can be used to compare different fractional amounts for equivalency. The strips can be presented to students electronically or printed, and they could appear in various colors and sizes. Fraction strips help students to visualize and explore fraction relationships. In particular, they help students develop a concrete understanding of fractions and mixed numbers. They help students investigate equivalency, compare and order fractions, and perform number operations with fractions. To the right of the screen, I've included some images of different fraction strips and towers. And just to note, some resources may call fraction strips towers, but I believe the terms are interchangeable. So a fraction strip and a fraction tower are the same resource principle. So in light of what I've learned about fraction strips and towers, I believe that students would be using these resources um, to compare and order fractions when it came to answering the lizard problem. So here we have three different strips, and as you recall, in our problem, we had one lizard that walked 3/8 of a mile. As we can see here, this student has divided his whole into eighths. The other lizard walked 3/4 of a mile. As we can see, the student has divided their other strip into quarters. Now, some students may cut out their fraction strips and manipulate them. In this instance, the student has just colored in the fractional amounts. So up here, we can see 3/8 versus 3/4. And so this strip is a clear visual representation of 3/8 compared to 3/4. And so the student could see here that the lizard that walked 3/4 walked the longest distance. In conclusion, I think that fraction strips and towers, if employed correctly, would be impactful for student learning because they're a resource that can aid students in problem solving, in communicating, in reasoning, in making connections, and making estimations. So it is definitely manipulative that I would use.